Now let's come to product management. So what is different in building AI products? Actually, to be frank, it's mostly the same. To do good at AI product management, you first need to be a great product manager in general, right? You still need to do all the things that a typical product manager would do, right? Which is doing product requirements, right? Voice of customer, problem solving, product positioning, UX design, go-to-market strategy, all of this stuff. So this does not go away, right? All of this is important, continues to be important. On top of this, right, there are some key differences, right? There are some key differences. So let's talk about 4 key learnings that I've had, right, in my experience in the last 10, 15 years. So the first key difference is you are working with multiple stakeholders, right? And you're working with more stakeholders if you deal with AI products. Let me give you an example, right? So here are all the key stakeholders that you typically see as a product manager, right? You are at the center and you're dealing with engineering, customers, customer success, marketing, sales, and so on. This is obviously a simplified view, but this gives you an overview in terms of how complex, right, the product management role can be. Let's focus on product management and engineering, right? Because these two are the teams, right, which work together to actually build something, right? The other teams are around this, right? But these two are the core teams which build this. So what happens in a typical product? In a typical product, product management, along with UX, I included UX as part of the product management bucket here. Along with UX, you define requirements, right? This can be product requirement documents, right? Or user stories, or they can be actual wireframes, right? And UX mocks. And you provide these requirements to engineering and you iterate with them, right, over a period of time to actually build and ship the product, right? This is what how a traditional product management lifecycle works, right? Everyone is aware of this. What's different if you're building AI products is this. Suddenly, there are 2 new teams who are entering the mix. So the first team is data sourcing and annotation. So these are the people, like for example, the example that we talked about, right, which is, hey, can you detect cats and dogs? To do that, you have to provide images, right, training data sets to the model. But how do you do that? If it is only cats and dogs, maybe like say 100 images of cats and 100 images of dogs may be okay, right? But if you're building a classifier, right, for all animals, right, maybe like say all animals in the cat family, right, that itself is like say 100 or 200 animals, right, in the cat family itself. How would you do that? You'd have to get images, right, for each and every animal like tiger, lion, panther, bobcat, and so on, and source them, annotate them, right, saying that, hey, this is tiger, right, and this is like if there are multiple animals in the same image, you have to annotate them specifically and so on. So there is an entire role here which is just focused on how do you source data, right? And this data can be in thousands of, like say in the case of computer vision, it can be in thousands of images, right, or millions of images. Or if it's in the case of like say credit card fraud detection, right, it'll be in terms of getting data across hundreds of thousands of transactions or millions of transactions which happened previously, right? So getting this data is very important. The second aspect is the science team, who are essentially taking this data, right, and building the models, right? And again, this is a continuous process, right? You build your models, you see whether the models are working fine, then you may ask for more data and so on. And then finally, you have the engineering team, right, who's essentially taking in science models as one of the inputs and building the overall product. So essentially, the complexity of building the product has gone up significantly. So what does this mean? This means that if you are spending time right now with your engineering team, right, to actually working with them to ship a product out, when you think about AI products, you're literally spending twice the time, right? Your coordination time goes up, right? And this is very critical to actually do this right. It also means that you have a longer lead time for product iterations, right? Because when you get feedback, right, if you want to change something in the product, especially if it impacts the AI models, Then again, you have to start the process. You have to go with data, right? Find if you have to get new data, if data is missing. The science team has to build the models, right? And then engineering team needs to ship. So these teams that I'm talking about, I mean, like again, in small company, like you may not have separate organizations or teams, like everything may be done by the same team and so on, but the roles exist, right? And this complexity will be there. So that is something which you need to think about. So the second difference, right, with AI product management is ambiguity. So fundamentally, you are dealing with more ambiguity in AI, right, compared to other products, right? Again, let me give some examples to illustrate this. So the first thing that you need to take a step back and think about is, hey, do you actually need AI? You need AI to solve this business problem or not, right? And let me explain what I mean by this. So let's look at this example, right? This is a web form, right? Typically, you'd have seen many of these forms on the web. Like this may be a form where you're onboarding someone onto health insurance, right? You're asking these questions. So a typical question for a product manager is, how do you optimize this form so that you can reduce the number of questions you're asking, right? And reduce customer friction and get more and more people to answer. So let's look at these two questions, right? Which is, what is your gender and are you pregnant? If you want to optimize this web form, right? One way is you can use AI, right? What does it mean? You collect thousands of customer responses, you build an AI model, and the AI model, after analyzing these thousands of customer responses, will identify a pattern that, hey, if the answer to question 3, which is, what is your gender, is male, then don't ask question 4, right? Because question 4 is always marked as no, or it's always left as blank, right? But you didn't need AI to tell you that, right? You can use common sense, right, to actually optimize that. So don't force fit AI when simple business rules can solve the problem, right? So the first thing I'm telling is think deeply, right, before you actually jump into this AI world, right, to solve the business problem. Second thing is, hey, now you have decided to do this, right? But how do you go about it? So one of the key aspects that you need to solve is the science problem here. So all AI models want high accuracy, right? Without fail. Everyone wants 100% accuracy. But what does it mean? Let's take an example, right? Let's take an example of credit card fraud detection, right? Very, very important, right? Very common use of AI right now. So let's start with this, right? When you want to remove fraud, right? If you want to improve fraud, or if you want to improve fraud detection, what is more important? Is it important to deny a fraudulent transaction? Or is it important not to deny a legitimate transaction, right? And these two are opposing forces. So let's do a quick poll, right? And again, go to the same slider.com website, the same code, and like to get your answers to this. Okay, this is very interesting. This is actually a very hard problem, by the way. Okay, so I see, I mean, people slightly preferring that it's, okay, actually it's going back and forth, right? So I'm seeing like roughly split, right? The audience roughly split between denying a legitimate transaction or not denying this. So this is actually a real problem, right? I mean, if you want to really design the system, you have to think deeply about this. What is more important? Because when you start building the AI models, this is what the science team will ask you, which is what is more important? Because based on which one is more important, they'll have to tweak the models accordingly, right? And I don't have an answer here, right? But these are the kind of questions that you have to think about, right, when you solve for this. So let's move to the next question, which is, hey, you said that, okay, maybe one thing is more important, right? It's not completely important, right? One thing is probably more important. But let's come to the second problem, which is, hey, maybe you said that, hey, I don't want to deny a legitimate transaction, but even there's a measure of accuracy, right? So how do you measure accuracy, right? And what level of accuracy is okay from a business standpoint? So note that increasing accuracy has a cost, right? It has a cost in terms of amount of time you build the model, right? Or maybe cost in terms of like say the amount of time it takes, right, to respond to the customer and so on. So again, let's do a poll. What level of accuracy is okay? Would you be okay if you miss one fraud in 100,000 transactions or miss one fraud in 10 million transactions, Okay, a lot of people are saying 10 million transactions. So I'm great that you have very high standards. But note that when you have these high standards, the cost of actually developing that model also goes up, right? So 1 in 110 million, right? Just think about it. It's essentially 10 to the power minus 7, right? That is accuracy you're looking at. Hey, so 10 to the power 7, that is the level of accuracy that you're looking at, right? So which is very, very hard to achieve. So again, there are no right or wrong answers here, right? And this is where you really need to apply business judgment, right? You really need to think hard in terms of, hey, what is the cost of solving this, right? Because if it will take me 1 year to develop something, to develop a model which is so accurate, like 10 million transactions, right? I'm losing 1 year, right? Maybe it's okay to go with, because if you have nothing right now, something is better than that, right? So maybe you can go with a cheaper model, which does something like 100,000 transactions, and over a period of time, try to improve accuracy, right? So again, these are the kind of problems you need to solve. The reason I'm bringing this example out is these are the questions you have to answer for science, right? Because scientists, just as engineers, will think very precisely. And unless you disambiguate and provide clarity, right, they can take a lot of time, right, solving the wrong problem. So something to think about. Let's look at another difference, right? And this is bias. Uh, so if you go on to the web and search for AI bias, you'll get a lot of articles. But essentially, what bias is, where it's an anomaly in the output of the machine learning algorithms, and it is caused by some assumptions, right, which are made either during algorithmic development or prejudices in training data. Let me explain. Again, this is a very deep topic, right? You should do research offline on this. But let me give a couple of examples to illustrate what it is and why it is critical, right, for AI product management. So let's take an example, right? Like as I said, again, in AI, you have a training phase, right? And so here, your objective is you want to create a face recognition model, right? You show a face, it will tell who this person is, right? Based on some reference faces already available. So let's take an example. If you take a training set, and in your training set, you only have dark skin tone faces, right? For some reason, right, you're not able to get all different faces. Most of the faces are dark skin tone, and you build a face recognition model. Now, if you put this model in production, what will happen? The moment a light skin tone face shows up, right, your model will get confused, right? It may still output the correct result, but then as more and more light skin tone faces show up, right, the model starts misbehaving, right, and it'll start giving errors. So this is a very classic problem. In fact, this is very prominent in face recognition, right? Which is, how do you ensure that your data set is balanced, right? It should be balanced across demographics, ethnicities, right? Skin color, right? And age groups and so on. So think about this. Again, you have to start from the business problem backwards, right? And look at how should you balance the data set, right? So that you're not by accident introducing bias into your system, right? So for example, you may not start with saying that, hey, I want to deliberately do it with dark skin tone faces, but as you're sourcing the data, as you're collecting the data, this may happen, right? And then you'll have a model which is not performing. Let me give another example, right? And this is actually a funny example, right? Which is how bias training data sets can lead to wrong outcomes. So this is actually a famous example, right, where people want to detect skin cancer. And these are examples of training images, right? So you can see the skin cancer image. And then typically, like you also have a ruler here, right? Because doctors want to measure the length of the tumor, right? And all that stuff, right? So this is very typical. What happens is, and this actually happened, uh, in real life, when you actually showed an image which did not have a ruler, it actually could not detect, because the model was always correlating the ruler to the skin cancer image. And when the ruler did not show up in the real life image, right, actual production, it did not detect. So let's be careful, right? I mean, let's be careful that we are building skin detectors, skin cancer detectors, and not ruler detectors, right? So again, how imbalance in data set, right? How biased data sets can lead to wrong outcomes. Now let's come to the last one, which is feedback loops. I think feedback, everyone knows as a product manager that feedback loops is very critical, right? It's very iterative to build products, right? Great products. But here it becomes even more important because, as I said before, machine learning is probabilistic, right? And inherently, when you have probabilistic systems, you need more and more data, right, to actually improve the quality of the output, right? Because you may build something assuming certain data in mind, but then in real world, you may see that, hey, the data is actually different, right? Like the example that I gave with dark skin tone and light skin tone faces and so on. So how do you embed feedback loops, right? So, so one way is you actually get this feedback by embedding a feedback loop in the core customer workflow. So this is an example like of TripAdvisor, right? And this is a reviews and ratings page, right? And this is an example review here. And what they have done very nicely, right? And inside the workflow is they have added this like button. And this really is a feedback signal, right? When you click on this, you're giving a signal to the model, right? Their reviews and ratings model algorithm that, hey, I like this. And this is real user feedback, which is going into the training data set to improve their model, right? So, and from a user experience standpoint, it's so natural, right? You're not breaking the user experience to do this, right? So try to look for such feedback loops. Another way to do this is try to get customers to opt in to share data, right? Because getting the data is so critical, but at the same time protecting privacy, right? A simple example is which you find a lot, especially like say when you are like installing a new mobile app or anything like that, right? Which says that, hey, help improve our mobile app by sharing usage patterns, right? Again, this is a great example where your data is being used to improve models inside the app. Again, this is a pretty controversial topic, so I want you to make sure that you are aware and conform to data privacy regulations, right? Because it's very important that whatever we're doing is ethically correct, right? So, so we need to do the feedback loop, but we need to do it the right way.